right. Hello, hello. Hello, hello. We should be live. So today we are looking at the examiner report for paper 2. This was the calculator paper, the first calculator paper of the 2022 exams. And we're going to be walking through that and talking about things you could improve. And T-Formula is again joining me.
Hello there.
So make sure, please, if you're watching this, to check out his YouTube. Hello, Elias. Hello, Aladdin. Please go to T-Formula's YouTube, subscribe. He's doing really good stuff. If there's one video I could recommend, it's his video on quadratic turning points. I thought that was really useful. He goes through lots of examples. That's a really important skill, and it's one that's easy to forget. All of the intricate details, the little details about finding turning points from quadratics, and you know, there's tricky questions they can give you on that topic. So I thought that video was really useful. So yeah, please go to his YouTube, subscribe, check out his work. He's doing great stuff there. And he's also covering topics that I'm not covering and doing things that really nobody else is doing. If we could, work on getting his subscriber count up. If you're watching this, please go ahead and subscribe. It's absolutely free, as it is for every channel on YouTube, so there's really no downside, unless for some reason you don't like learning. So check that out. Also his Instagram, and he's on Instagram and TikTok. Okay. So we have the question of the day. This is related to one of the questions in the exam paper that apparently students were struggling with, so we thought we'd make it the question of the day. And before we get into that though, we had a few comments in last week's show talking about, issues with learning about mathematics, maybe not feeling confident about mathematics, and maybe feeling some maths anxiety. So we thought we'd start off by talking a little bit about maths anxiety, and what that is, and maybe some things you could do to manage that. So firstly, let me make sure that you can see this properly. I'm having a bit of issue with how it looks on the screen. Hang on, just 1 second. Okay, there we go. So, what are the signs of maths anxiety? There isn't a formal test for maths anxiety, but a situation involving maths or even the thought of doing some maths can bring on the following recognizable reactions in people with maths anxiety: feeling panicked or stressed, feeling flustered or struggling to concentrate on a calculation, increased heart rate, sweating and nausea, and avoiding situations which involve maths. Professor T-Formula, have you worked with people that suffered from maths anxiety, or is this something you kind of see much of, or do you have any kind of strategies to deal with this?
Absolutely. I actually see it all the time, and I don't think it'll ever go away. Most adults will experience it at some point, and in fact, girls and women are more commonly affected, and it affects people quite badly. Sometimes it's only short term, and it's not really a product or indicator of how good you are or your academic achievement. The stress that comes with the condition can affect your performance and your situational awareness and stress in tests. And, it can make the anxiety a lot worse, and you feel like you're caught in a cycle. And well, I mean, the thing about what brings it about are I guess there's a lot of reasons, but one is very pressured situations like being judged in the classroom. And I think we've all had that experience when we're in the classroom. You have to produce an answer, or if you're in an exam and it's like that's your final shot. And I suppose in that sense, it's not just maths, but maths seems to be very judgy. Um, can have specific negative experiences. We talked about the work that I did with students in A level where they have to resit their GCSE because they had a really bad GCSE experience.
Mm.
And, that was the thing that turned it around was having a conversation about that one point where they had a negative experience, talking about it and just telling them, I'm going to be there for you. And we can just talk about these things that you keep inside you, and that really it's very common. It's not just you. And this is particularly in maths. I think a lot of maths teachers have a lot to think about when it comes to how maths is taught, especially in primary school. I was in Scotland, I was a specialist in primary school, and I was teaching the teachers in primary school how to better improve their maths teaching because really they do every topic. They're not specialists.
Yeah.
And the biggest thing, that really holds you back from a happy experience is somebody that doesn't know maths but just still wants to be correct. And so, you're forced to accept some absurdity. And that can be your experience in maths. You feel turned off from it because somebody who's apparently knows what they're doing told you haven't got a clue and you start to doubt yourself. It feels really bad. So yeah, there's a lot of stigmatism. You could be judged that way. But there's also a lot of ways that you can improve it. For example, recognizing the emotion. A lot of us, you know, we have that panic and stress, and just recognizing it won't probably make it go away brilliantly, but it's an important first step. And it might be the way that you feel now, but it definitely won't be forever. And if you keep up that practice, that definitely helps. I can say a couple more, and then maybe you could chime in if there's any like how to address the maths anxiety that you've found that worked. I think, as I said earlier, talking it through is really good. There might be just that one thing you don't even know what it is, but it could be just the smallest thing, and we can turn it around if we could just have a conversation around it. Um,
Yeah, I
and
I
yeah,
remember seeing a statistic somewhere that as much as 1 in 4 people suffer from maths anxiety, and I feel like it's an issue that is for if it's that large, then it's not talked about nearly enough. Like I don't think I've ever heard it talked about in schools. I certainly was never. It was certainly never addressed when I was a student at school. I think, well, in general, mental health issues are not talked about enough. But in something as specific as this, I think if that many people are suffering from it, it could be. I mean, I think there's a lot more we could do to um, to make people aware that it
yeah,
exists. Like it's like for a lot of people, it might be surprising that not everyone feels these things about mathematics. I think a lot of people think it's just natural to feel panicked or stressed when they have to do mathematics, but that's not. I mean, that shouldn't be normal. Um,
no, it's
and and
certainly not
it's
in my
and it's
classrooms.
certainly and it's something we can work on and improve on. Um, um, so if we can work on these things, then I think that would help a lot of people, especially if that statistic I'm remembering, whether that's correct or not, is true. Um, and
It's
yeah,
pretty high, but you know that part of being good at maths, or I mean, it is part of it, and you can't really separate that, is competition. It's a very competitive subject. And really, that drives a lot of it because that builds a stressful environment. And nobody likes to be put on the spot and made to feel stupid. We've always had that one person next to us that makes us feel really bad because they can do it and we can't. But as I said, every last week, everybody's got their own journey to go on. Even if you're taking 2 weeks, you need to fill in the gaps that you need to. And by that time, you may be ahead of everyone else.
Mm. Yeah. So, so yeah, as you said, recognizing that it exists is really important. Then talking about it, um, making the time to
Yeah.
uh, when ready to give some sums a go, it can help to grab a copy and get away from anything else for a while. Ideally, somewhere relaxed, so it doesn't feel like a test environment. If time is stretched, doing just 10 minutes here and there works well. Okay,
That's a good one. That's a
s-
good one. Just relaxing and chilling out
so making
and
it less
easing into it.
stressful
Yeah.
to do mathematics. Mm.
And it's about having that positive attitude towards it. We talked last week, and it needs repeating, but you can be the author of your future by telling yourself daily how it is you want to be. If you want to be confident in maths, you start to tell yourself it's your favorite subject, and it does amazing things. Just like when you mentioned about smiling and it forces your body to be happy. It's crazy.
Mm. Um, and then overcoming maths myths, changing the way that we think about numbers can make a real difference to our self-confidence. It is helpful to remember that the ability to be good at maths isn't something we are born with. It can change over time, and we can all be good with numbers. Very good point. Um, Obviously, there's natural variability, but I feel like people vastly underestimate their ability to learn when it comes to mathematics in particular. For some reason, people just feel, oh, you know, I cannot get better at mathematics, and that's a strange myth, like that you're born with this magical ability.
No, but it won't happen overnight. And you just got to set achievable goals, those little bits that will slowly get there. And just don't give up. Isn't that a great mantra for life?
It sure is. Okay,
So I just mentioned before we move on then that
sure.
I've dropped a link in the chat. If you're feeling, anything like this, you're feeling stressed or you feel like you're trying to do your maths and suddenly something comes across you that you just feel daunted or anxious, then you can go on this link and it's a massive free resource and they assess how you feel about it, and there's a lot of good stuff to read on there and get involved in, and strategies that really can help, and look forward to a year of really a great positive experiences in your maths classroom, and that's going to be a fantastic help for your grade, right?
Awesome. Did you post the link already?
Yeah, links in chat.
Oh,
It's the nationalnumeracy.org.uk /what issue /about maths anxiety.
oh, I wonder if it got blocked automatically because I'm not seeing it, so
Yeah, maybe because you can't post links,
I'm not
but
sure.
we can get that out somehow. But yeah, someone said in the chat, what's the best method to study for math in your opinion? I've got my method. What do you think?
That's a really hard question, big question. Um, um, the best method to study for math, in your opinion? Well, I could speak about my own experience. Um, I generally just like to do problems that I like. So, for example, at high school and university, my revision looked pretty similar I take the homework problems, I do the problems in class, and that worked for me because I quite enjoy mathematics. So, you know, it's a kind of a boring example, but I would just kind of work on work on the problems at in class and in my own time. And if I ever got stuck, I guess the issue is a big problem is when you get stuck, what do you do? So you need to have a strategy for when you get stuck on a problem. Um,
That's part of anxiety, right? You've
mm,
got to have that go-to thing that says, no, it's okay, relax, and let's find a way around it. And sometimes leave it alone and pick it up the next day, even.
mm. Yeah, I've done that a lot. I'll have a problem that I can't do, and I can't do it that day, but I won't give up on it, and I probably won't look at the answer unless it's something I'm quite sure I can't do. So sometimes there's problems that you feel like there's a missing piece of information, maybe a formula you haven't learnt about yet, or a topic you haven't covered yet. And if you feel that way, then I think it's sometimes okay to look at the answer. Maybe think about the problem for 10-15 minutes. Um, but there are problems that I know that I feel that I should be able to do, and I won't, check any answer or look at any solution until I get it myself. And sometimes that can take days. There have been problems I've thought about for weeks, and eventually I do manage to get to the solution usually if I feel like I can do it. Um, and also, you know, another part of that is not feeling like a failure for giving up. Sometimes there are problems you need help with, like you can't do by yourself. There's just something you're missing, some information you're missing, and that's okay to essentially say, okay, this question I can't do it. I'm going to get some help, and that's fine. And then the next time you get stuck, maybe you'll get that one by yourself. So that's a kind of important skill to recognize when you can do the problem yourself and when you might need some help. And what about you? Any thoughts?
Yeah, yeah, definitely. I mean, we've all got different styles. And, so coming from somebody that loves math and who doesn't, it's going to be slightly different. And I'd say that in general, the wisdom around maths is practice questions. But there's a little bit more to that. So, just picking up a book and doing things that are easy is not good. You want to keep challenging yourself. And so I like to start with making sure that everything, well, apart from attendance is actually quite important. So make sure you attend every lesson. But everything that I get given, every question, if I've got a book to work through, I'm going to do every single question. Because this person who asked this question is literally at GCSE level, where a lot of it is going to be memory. And as sad to say, but it is. So it's going to be about practice and repetition so that when you go to the exam, what you're looking at is not going to surprise you, and that you want as much as possible to be committed to a habit. Because if something is not a habit, it means you have to be consciously aware of it in the exam, and you're not in the right state of mind to do that, I'll be honest. So you want to make sure you've got like the strongest habits from repetition. And it looks like what you're saying there, that you work well with repetition, and that basically is how GCSE works. I work through the book, and as soon as possible, I get myself onto the exam questions. So what that means is I'm increasing the complexity. I'm always looking for those past papers, and I'm thinking about those questions and finding questions that I haven't got a clue how to handle. Those are the questions that I give myself a task to figure out.
Mm,
And there's always people you can ask. You can ask us online in the forums. You can go to your teachers or parents if you're lucky enough. And then what I do once I've exhausted the exams, I make sure that I get what I want by doing challenges. So that's the UK Maths Challenge, those sort of questions that you'll find on the Senior Maths Challenge. will really give your understanding a boost, because all of this increase in the difficulty is what I call complexity. The more things that you can handle at a time, the better you're going to do. If you go to a higher complexity than your examination, you will find your examination is an absolute breeze, very easy. And it's really what you're used to. As soon as you start studying for A levels, you will look at back at a GCSE, even a month, literally just a month into the GCSE.
Mm. I
You will
feel
look back at it and think it's super easy.
I feel like you would have a great answer for Yugami Light. He says any websites that can help me aim for grade 9 questions. I feel like those challenge websites would be great for that.
The challenge websites are perfect. That's exactly the kind of level that you want, because you need to challenge your complexity. You need to challenge your links between off curriculum topics, things that will get you there that are not necessarily stated obviously. But oh, I remember now, I think it's from Pixie Maths. I think they do it aiming for grade 9 GCSE booklet.
Mm,
And that's just contains grade 9 questions.
mm,
There's also this fantastic website, which I recommend to everyone that I tutor, and it's called therevisionator.com. No, 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 it's not revisionator. Oh, and you know what? I'm going to look it up now. What the Revisionator is like an app, right?
okay.
And inside this website, they got this thing. That's it, on maths. So
On
I need to
maths.
type that in the chat. So it's on
Oh yeah, he also
math.
has a YouTube channel.
Oh, they got have they?
Yep, pretty
That's
sure.
really good. They've got a thing on their website called the Revisionator.
Okay.
It's pretty cool because you could put it on your phone, you could do it on on the PC, but any amount of time that you want to spend, 5 minutes, half an hour, you pick your tier, which is higher, and they just shove questions at you over and over, and you do as much as you can manage. And that'll be a way to find questions. They'll get thrown at you.
Mm.
I wanna finish with the idea, like something that helped me, which is beyond just the basic, that might help somebody else, which is
So
having
Obi Kenobi was saying, repetition works best for me, but if there are other methods that might work as well, that'd be great. So is there something
excellent.
you would suggest?
100%. So when I was researching learning in maths, there's an area of science called neuroscience, which deals with how the brain works. Not like how individuals work with psychology, but how the brain works for everyone. And one of the methods in there that's the most powerful, and which is having a maths journal. So you have this extra book. I recommend it to all my tutees as well. You have this book that you carry around with you to make a note of any further follow-up question that you have when you're in that moment, to make sure you don't lose that, but also to make a note of what you learned, to consolidate it in a different way. So today I learned this, and it was useful because of this. What you're really doing is saying, look, memory, this is important, and I'm going to write about it. And when you consolidate things in a different way than when you first learned it, it's doubly as strong. So I'm going to say, use a math journal and make a note of what you're aiming to do, little to-do lists, and how you felt about that lesson and what you'd follow up.
That's a great tip. Yeah. Thanks for that. Hopefully Obi Kenobi found that useful. All right. So, should we jump into the report?
Do it.
Okay. So this is, as I said at the start, paper 2, the first calculator paper of 2022. Shorter introduction on this one. They say it was very pleasing that despite the 2 years of disruption, students were well prepared for this exam, and most were able to attempt the majority of questions. Any thoughts about that? The whole Um, the whole COVID thing.
COVID thing for a lot of people, it's disrupted on two fronts, I would say. First, we have to become more independent learners, and not everyone has been the best at doing that. But there are certain students that have always been that way motivated, like internally motivated,
Mm,
that may not have been affected. What it's really been affected, what it has affected, is the people that A, don't have access to technology and the internet at home, and B, those that really need school and people and support to be motivated enough to study for maths. And I
yeah.
think that that has been a real challenge because school is, apart from annoying, it is actually really good habit to have. And it's, you miss it, I think, and the people have done that. The fact that it's, people have come away strong might be because we adapted after the first year of COVID and we learned how to teach ourselves a bit better. And really, COVID after the first year, we did kind of come back face to face. So I'm hoping, that's an upward trend from now on.
Mm. Yeah, it was. It was. Well, I think some schools did really well in kind of adapting and quickly to kind of getting their team set up, and like working online and all that kind of thing. And but yeah, it did affect people in different ways. Um, Obi Kenobi says, I sometimes write notes for maths with hard topics to memorize a method formula. And maybe now you could formalize that a bit more with a maths journal, possibly. There's an idea. Yeah. All right. So, question one was, I think, indices. Nothing too interesting.
No,
Says
super basic by the looks of it.
just probably some small mistakes. This
Nice, nice start to the paper, really.
A pleasing proportion of students gained both marks for the correct working. Okay, question two. This description of a translation was unfortunately not answered as well as would be expected. This surprised me, although I feel like there might have been a small trick in there that kind of just caught people off guard just for the fact that the question says, describe the transformation that maps S onto T, and perhaps people are looking at T mapping to S because, it's left to right. You just read left to right naturally. I don't know.
I think that's a good summation.
But yeah,
But I think people confuse. There's always a bout of people each year that confuse coordinates with vectors. So it could have been that we're writing the format in the wrong way.
the answer as a coordinates instead of a vector.
Yeah,
Okay, yeah,
yeah.
could have been also, yeah. Yep, I mean, transformations is really it's one of those topics that you can learn and even memorize, and it's not one of these topics that they can hit you with something out of the blue. Like, it's really like all of the skills are there, and there's only a certain subset of questions they can really give you for that topic. So I think it's a topic that you can totally master, and and hopefully we can improve on that in the future. Uh, so upper and lower bounds was done well. That's good. That was a new topic for, I think, a couple of years ago, introduced a couple of years ago, or a new topic in the new specification.
New spec, it's pretty good. Yeah, look at the way that they've taken the inequalities problem out of the you're doing because they've put the inequalities already. So as a hint for you, you just need to know how to get the upper and lower bound there rather than the actual
Mm.
um, error interval, which is nice.
Yeah. Uh, Question 4. Yeah, these calculated papers I think generally done quite well. So, question 6, standard depreciation question was generally answered well. 7 and 8. Oh, question 8 was another familiar question answered well by many. Uh, what was question 8? Oh, yeah. Question 8
Looks
was
pretty
one of those
disgusting.
stick it into your calculator. Um, and so I
You know, we're
just,
ta we're talking about these questions here. I can see it. Is it okay to share that, or do we just have to talk about it?
um,
I think
yeah, I
the
mean,
way that this question looks is rather off-putting, and I think just a quick glimpse is,
yeah, so we can talk about it for sure. So the thing I wanted to highlight was, uh, they said students need to make sure they're able to use the power button correctly on their calculator so they're able to process complex calculations. I thought that was an interesting insight. So people are having trouble with inputting certain things into their calculators or forgetting how to do, complicated calculations
yeah,
on their
that's
calculators.
actually always been an issue. In fact, today at university, I was trying to calculate, well, one of my students were trying to calculate something that we thought was quite basic, the sums of squares for the x direction, putting in loads of brackets and completely getting the wrong answer. And we just break it down bit by bit and tell the calculator exactly what we want it to do by using brackets because can't really trust it, can you? You have to force it to do what you need it to do in the right order.
It can be tricky. I think is that like I remember spending a lesson with the calculators. Well, I think everyone does this, but I think I did it with the um, grade 9 class, and one of the um, what are they called? The subject coordinators, whatever they're called. I can't remember what they're called in England. Um,
Head of
came
department?
Head of department, yeah, came in and was observing, and afterwards he said, "You spent that whole lesson talking about how to put things into a calculator. You think that's worth your time?" And I would still defend that and say that was time well spent, because getting used to using a calculator is important for these calculator papers. Um,
Yeah, not only that, if you study A-level maths, then every exam includes a calculator. And not only that, you have to have a calculator, a very specific one. And this is used heavily now because we understand how technology can help us do the things that are not necessarily needed to be done by hand anymore. So it's becoming a bigger and bigger thing.
yeah. Question 9. Oh, they had to use a pressure formula. Question 9 and 10 were. Question 10 was a box plots question, performed very well. Question 11 was, they said inverse proportion is a topic that many students find difficult. I would agree with that. Uh, I'm not, I can't exactly explain why, but that just in general, looking at relationships between things that are inversely proportional, I think is uh, um, well, it's not as natural, obviously, as looking at things that are directly proportional. It's just maybe it's
Well,
just as simple as that. I don't know.
I think the graph is very strange too because you look at directly proportional and that's a straight line graph and the relationship is clear, it goes through the origin. And then inverse, suddenly it's an exponential graph that's going down and and it's very unnatural to spot that sort of pattern. Much easier to spot a pattern where it goes up by the same amount each time.
Mm. Yeah, and actually, I would have called that a work rate problem, but um, I guess it's also in proportionality. I don't know. I never really know how to categorize these type of problems that say like, you know, 6 workers can do it in this many days. How many, how many days would it take 13 workers? That kind of thing.
I'm calling it proportion.
Proportional.
Or maybe you could call it Christmas cracker questions, because I always
Yeah.
remember getting that question around Christmas dinner table. And as the mathematician, I'd have to be the one to answer it in under 5 seconds. Otherwise, I'm no mathematician. The pressure and anxiety comes.
Yep. Um, Question 12 was fine, although they said it was answered better than in previous papers, so it's good to see that improvement. Question
So question
12.
12 was about lines and straight
Yeah,
line graphs
yeah,
and, show that these two lines are parallel.
finding the gradient.
We could have asked a much worse question, be honest.
Yeah, yeah. Sometimes they can be tricky. Question 14 says Pearson's capture recapture method is one that is becoming familiar to students.
Good. I
I
love
ha-
that idea.
I'd never heard of this. What is
I
Pearson's
wonder, I
capture
wonder if
recapture?
anyone knows about this method of sampling in the chat. I mean, the idea is that if you've got an unknown population out in the wild, there's no way of knowing what's out there at any given time, unless you're this sort of godlike figure who knows everything, right? So, oh, and also they don't have unlimited resources. They can't go out there and put a tag on every single one of them. So they use this assumption, and let's say one day they catch a certain number of fish. Let's talk about it from a lake point of view, right? So we know that there's roughly 10,000 fish in that lake. Well, we barely know anything, but let's just say there's a lot of them. And we go one day and we catch, I don't know, 100 of them. And we then release them back into the wild by after tagging them. So they've all got this special little tag on or way that we can tell those were the 100 that we initially captured. Now, the assumption is that they're going to spread out evenly amongst the entire population, right? So those 100 are now evenly spread out everywhere. So now if we dip our fishing net into the lake at any single point, we can capture a new population which will contain the proportions of the entire lake. So let's say of the 100 that we let go, we pick out another 100 in a week, and we see that 20 out of the 100 have that special tag that we gave them. And if that little 100 that we just took represents the entire lake, that means that the original sample that we had of the 100 represents 20 out of 100, which is 20%. So we can make that assumption that 100 equals 20%, and therefore 100% will be 500. So there's 500 fish in the lake. It's about proportions and the assumption that they spread out evenly.
Hello, Cynical Frog. Welcome. Yeah, makes complete sense. I just never heard this phrase, Peterson's capture recapture method. It's just very specific. Is that used in science or is that
Yeah, because
okay?
you, as I said, if you're looking at endangered species, you want to know how many there are without disturbing them too
Mm,
much, or because you don't have much money, you capture a few and you assume that they will then evenly disperse in the population. There's a lot of problems around that because what if they die? And that happens a lot in systems that they don't live very long, or they're very much survival oriented. And the other problem is, what if those 100 that you picked, they don't disperse? And then you go back again, and it turns out that you just grabbed a whole family and they stick together, and then you pick them out again, and let's say all 100 of your second sample are tagged. Well, you would assume that there's only 100 out there in the wild, but there's always downsides to any sampling method. We're just trying our best.
Mm-hmm. So that was question 14, and they said, yeah, they were familiar with it and they were able to start the problem. They were unable to form this into a correct equation. So they were unable to kind of use that reasoning you were just going through to find the percentage,
I think it
unfortunately.
would help to actually go and do it. As a maths lesson, you could go out into the local forest or
Yeah.
something, actually do something.
Yeah, that'd be great. It'll work with some classes better than others, but yeah, that'd be good. Question 15. Many students struggle to start this problem. There were two main methods to solving this problem. The first method was to use the two ratios to form an equation. Okay, so this is the question that formed the question of the day that is on the screen. So a to b equals 6 to 5. A plus 1.5 to b plus 1.5 equals 13 to 11. Find a and b. So this was something we identified as an issue in the exams. So we thought we'd make it a question for you to have a go at. So I think one of the issues with these ratios problems is realizing you can simply, I don't know why that stuff was written down there. You can simply write ratios as fractions. So that's something I think, I'm having trouble with my pen. That's something I think is an important point to point out, right? You can write a to b equals 6 to 5 as simply a over b equals 6 over 5. Okay? So that those two statements are equivalent. And then you can say this implies that 5a equals 6b. So there I've created an equation that looks possibly much more helpful than the original ratio, saying that 5 lots of a equals 6 lots of b is probably going to help me find the values of a and b. Although there was a shortcut to this problem as well. So you can solve it by creating equations. You can also recognize there's a little trick that you can use here, which I guess we can go through also. So yeah, the first method was creating equations with these ratios. The second was to say to create an equivalent ratio. So to say 6 to 5 is the same as 12 to 10. And then if we're adding on 1.5 and then we get 13 to 11, we've added one part to each part of that ratio. Right, we've gone to from 12 to 10 to 13 to 11. So we've added, essentially 1.5 is equivalent to one part of that ratio. Does that make sense?
Yeah, I don't know. I'm looking at the live stream on my phone, and I don't see what you've done there on the live stream. I don't know if it's just me.
Okay. Well, it wasn't that important anyway. I wasn't writing anything particularly useful. But yeah, so if you recognize, if you add on 1.5 to a ratio, such as 12 to 10, and then you get 13 to 11, that means 1.5 is equivalent to one part of that ratio. That means to find the value of a, you multiply 12 by 1.5. So a is going to be 12 times 1.5. which is 18, and then B is 10 times 1.5, which is 15. So there was a little shortcut there. But I would probably suggest sticking with the longer method, which is creating equations with those ratios. But yeah, that's a topic that is worth practicing because it's one that often trips up a lot of
How
people.
many
And
marks? How many marks is that one?
that was 4 marks. So
Mm.
yeah, quite a lot.
Technically, you've got to train yourself to do that in 4 minutes.
Yeah, and they say students looking to earn higher grades need to practice more with using equating ratios to forming equations. So as I said, a key skill that is definitely worth practicing.
Mm.
Basil says, do you have your A-level mechanics videos uploaded? I'm not sure what you're referring to. Which mechanics videos? And then I can maybe help if you try to be a bit more specific. Sorry. Question 16 was on Venn diagrams. At least that was a tricky one. Yeah, Venn diagrams are sometimes quite difficult. But
I can
yeah,
say about Venn diagrams,
okay,
this is a three-circle Venn diagram. And the only real thing to recognize when doing this is to start from the center. So that where it says 4, use all 3, that goes in the center. The thing where people go wrong is where they start on the outside and you'll get contradictions that way.
okay, good tip. Question 17. This volume problem requires students to work with a hemisphere and a cone. Oh yeah, so they say firstly they didn't halve the volume of the sphere to find the volume of a hemisphere. This is such a common mistake, and it's understandable. Like when you're just learning about 3D geometry and you're learning about volumes, it's understandable you're going to make mistakes. And when you're just learning how to find the volume of a sphere, and then you're also asked to find the volume of a hemisphere, maybe it's not, it doesn't come naturally that you divide the formula by 2. So I understand, but it is a very common mistake when looking at volumes of three-dimensional shapes, that it works usually just the same as when you're working with 2D shapes. If you're looking for the area of a circle, and then you're asked to find the semicircle, you need to halve that area. So whatever formula you have, so if you're looking at pi r squared, just divide it by 2. There you go, you've got the semicircle. And yeah, I don't.
I've got to add in a tip there, by the way.
Mm,
The issue that was going wrong is a general issue, and it's when you're doing things in multiple steps, you don't really know what you've done as you go along. So, you're lost halfway through the question, and that's a common thing that happens. People get lost and they don't know what to do next. And one of the important things, especially in these questions, is to write down what you've done as you go along. Just label it. What exactly have you found? And get used to that. And, maybe you can't do that straight away. It requires you asking in class or writing in your math journal something to reflect on, that you are fully aware of what you're calculating at any given point and why. And if you can always ask yourself why, even if your teachers don't, even if your parents don't, always ask why, you're going to do yourself a great favor, a great habit to have.
yeah. I'm wondering, the stream might have dropped out at some point. I'm not sure. I hope there wasn't any issues with it.
I've gone out and in a couple of times. Maybe others have as well.
Alrighty. Yeah, but I was just watching it back briefly there, and I noticed that it's quite behind. Anyway, we'll try to sort out any technical issues for next week. Um,
So we're basically time travelers right now.
maybe. Yeah, I'm not sure. Um, yeah. So being aware of what you're actually calculating is I guess the the next step, as opposed to just plugging into formulas.
Yeah, yeah, definitely. Like always write down what it is you found when you got the result. So if you are calculating the area of the sphere, you say, okay, that's 49 centimeters cubed for the volume of the sphere. And then in the right of it, you write in brackets volume of sphere. And then that tends to really jog and cement. And if you get lost trying to think about the next step, at least you can go back and then read what you've just done and start again, not from the beginning.
Mm. Yes. Yeah, so yeah, I thought I'd just highlight that as a common kind of place where students trip up volumes and kind of, as you said, I think that was really well put, being aware of what you're calculating as opposed to just kind of plugging things in or just writing down formulas. Yeah, and labeling things as you go can be really helpful, as you say.
Always ask why in class. It's a great question.
Mm.
Even if it's only yourself, ask why.
Always ask why. Question 18. This trigonometry question was again a familiar style and provided access to marks for a good number of students. Okay, so question 19 was fine. Um, question 19 was functions. I think functions is another topic that can be difficult. Um, although again, it's one of those topics that you can like learn. It's very logical. You can learn about composite functions. You can learn about inverse functions, and there's not a whole lot there that they can kind of trip you up on. It's if you if you get those skills in place, then you're very well placed to do well on these questions.
Yeah, at GCSE, they don't require much more than just do it, do they?
Yeah, pretty much. Yeah, in GCSEs. Good point. Insert. How was your day? Very well, thank you. How was yours? Question 20. This circle theorem. Oh, circle theorems. Circle theorems, not the most popular topic. This circle theorem question proved to be challenging to many. So I think there were two theorems you needed for this question. Yeah, so
Number 20, I see
yeah.
all sorts there. There's the trick, isn't it? Where you get the cyclic quadrilateral, which is a four-sided shape that's supposed to touch at the inside of the circle at every single point. And then here, one of those vertices is in the center, and a lot of people still think that's a cyclic quadrilateral. There
Yeah.
is still a cyclic quadrilateral going on here, but they'll get confused on one of them, I think.
Yeah. Yep. Yeah, so you needed the angle at the circumference is half the angle at the
That's the one.
center, and then you need the
Yeah.
cyclic quadrilateral opposite angles in a cyclic quadrilateral, and and also angles in a triangle. Um, but yep, it's not easy to remember those, and there's not really, I mean, you pretty much have to memorize those, right? You've got eight circle
They're
theorems.
fun. There's a roughly eight. It depends how advanced you want to go. You can go up to 10 of them if you want to be particular, and even more. If you look at my Instagram channel, I've started to put some more advanced ones on there for the maths challenges, like Ptolemy's theorem and the intersecting chord theorem. And well, I'm trying to make them like posters really, because they're just to remember. But yeah, try and make your own poster and just
Hmm.
keep looking at them. Remember them.
Yes,
You've
But
got to
I
remember
don't
the
want to.
names as well.
I don't want to panic anyone. There is only 8, so I've looked through the specification, and they actually there's not anything in the specification about it. But for example, if they pulled out a question needing Ptolemy's theorem, that wouldn't, I don't think, be fair, right?
Oh, definitely not. But I'm just putting it out there that if you want to really remember them, I found as soon as I made those Instagram posts that I just don't forget them. I remember the formula. I remember what it looks like. It's really solid. So you can make yourself a poster of the circle theorems at GCSE.
Mm,
And if there's anyone listening that's doing the math challenges, you can see the important ones on my Instagram. And just saying that that was quite a powerful tool for me.
mm,
And you need to remember to use the names of those theorems as well. So having a poster up, I always say make just make posters. At GCSE, a lot of it's memory, so make posters everywhere. Have them in places that you're going to be sitting there with nothing else to do. I always joke about putting them on the back of the toilet door, or in the car on the window, or just or the back seat. If you're sitting there and you have to be in a car journey for a long time, or even on the background of your mobile phone, like the ones that you're struggling to remember. It's all to play for, and do everything you can possible to remember this stuff.
mm-hmm. Yeah, so check out T Formula's Instagram also. Uh, okay. How's everyone feeling about circle theorems? I want to see someone in the chat talking about circle theorems. So how do you feel about them? Echo, echo, echo. All right. Um, yeah, I really hope we're not having some technical problems. Like
I
I was
can I
telling you.
can work on typing it.
No, 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 it's okay. All right. Yeah, remember we were talking about this last week, the issue I was having. But, well, let's carry on anyway. Question, because there are people that will be watching after the fact, watching the VOD.
Yeah, yeah, yeah.
Question 21. Oh, this was pretty tough. So this was transformations, graph transformations.
Oh, it's the
Um,
worst one where there's a negative.
mm, yeah, I mean, this is, again, kind of a thing that you need to memorize. I
It
mean,
came from A level.
yeah, yeah. Or, so graph transformations were in the old spec, were they not? But the trig, I
They
think that,
were, but these more advanced ones where we're doing graph transformations more serious, this was more to do with A. We do it seriously at A level, and they've just made them slightly harder and more involved now at GCSE.
right, yeah. Um, uh, so do you know specifically, I guess, oh, that's a hard question, but yeah, I feel like there was something like the trig transformations, maybe they were added.
The trig transformations were there, but only
Okay,
basic ones.
all right.
So if you look at the one that they're being asked to do here, which is a reflection, this is a f of open bracket negative x, which represents a change in the x, so a reflection around the y-axis. And you're right, I think it's just a matter of remembering what is going on at which position in the notation.
Mm.
If it's inside the bracket, if it's outside, if it's positive or negative, those four things, and what you have to know about what it means.
Yeah, there's some ways of kind of like trying to figure it out, as in like, well, mm, if I plug in a Okay, so if you have a function f of x, you plug in 1 for x, you get a certain value for f of x. And then if you plug in the negative of that, you can maybe explore what would happen to the graph, but it's kind of tough, especially if you're given a general question like this where it's not a specific function, it's just f of x.
I'm going to say that it really helps when you write down, if you're going to plug it in, you say, let's say we're putting in 1, like you say at x equals 1. And then when you put it in, you realize that it's actually -1 that's gone in. You start to see, wait, at +1, when it goes in, I'm going to be plotting what's happening at -1. At +2, when the 2 goes in, the result is what's happening at -2. So yeah, I think you could certainly do that. I teach it that way
Hmm.
and play about. But doesn't it require confidence with this notation?
Yeah, and especially in an exam situation, it's tough. I think it's going to help a
Yeah.
lot if you kind of like almost, rote learn these transformations. As bad as that sounds, I mean, in class you can get the understanding, but you also kind of need maybe that repetition just to be really familiar with. As soon as you see f of negative x, you're thinking reflection in the y-axis, or like tan of x take 90. Oh, that's a translation to the right 90 degrees, and you kind of need that repetition.
Yeah, yeah, yeah.
Um, yeah, tough question. Kind of like one of those questions. If you don't remember that kind of thing, then you're probably not going to get the full marks. Uh, and then the last question, quadratic inequalities. That's a tough topic. Um,
That's a great question. It's something I need to tell everyone here. If you want to do well at GCSE Maths, you need to get good at solving quadratics. When you're good at that, you can do this question, which is the quadratic inequalities, like much, much easier.
yeah, true. In a way, it's just if you can factorize that second quadratic quickly, it's going to be uh, much faster to solve it. You're not going to be panicking. Oh, what's the factors of 72? Oh, how do I get to 31? Maybe you'll be faster, more confident at that. And once you
But I can't,
factorize that quadratic, um, I think it'll go smoothly after that.
I can't tell you how important it is to get good at quadratics because, and I'm saying it again, but because it's so important, the higher GCSE, if you're going to solve an equation, it's likely to be a quadratic. And so get used to solving it in a variety of ways. But more than that, don't just solve it, go on and sketch it. Because when you solve it, you're finding the roots, and the roots give you these great ways of positioning it so that you can sketch it. And if you make it a routine habit to go on and sketch it every time, like you're going to set yourself up for absolute success.
Yeah, I think we're lagging a lot for some reason. So Waha has just chimed in. I like GCSE circle theorems. Once you do enough of them, they become second nature to me. So I asked that question, what, about 5 minutes ago?
At least.
And then Farhan says, big up with your 2 viewers. Thank you, Farhan. He'll probably hear that in about 10 minutes and go, oh, he saw my statement. I'm
Yeah, no, there's just a big delay of what's going on here, so
not
it's just
sure,
disjointed.
not sure why. That's really strange. It did. I don't think we had that much of a delay last week.
Don't think so. Don't think so.
I have to figure out why. Maybe it's buffering at some point. Hmm. All right. Problem to solve for next time. Okay. Yes. So quadratics, make sure you're really confident with quadratics, and then those types of problems go much smoother.
I actually quite like this idea um, that they've combined multiple topics in one, and that's another reason to have the journal with you because you're starting to spread out and question where it links to other topics. So more and more they're doing this multi-topic question. So it's worth, reflecting on how everything is linked together.
Yep. And in summary, students should improve their use of calculators in general,
Hmm.
but in particular completing complex calculations involving powers or fractions. Um, Learn correct geometrical terms and use them when giving reasons in geometrical questions. I think that was in relation to the circles theorem problem. So when you're solving those circle theorem problems, you need to give reasoning for your steps, and making sure you say like the angle at the circumference is twice